We're picking up now from where we left off on our previous video. These are extrema on an interval I. And this first statement is what we've talked about before. F of c is a minimum value for f of x on I if f of c is less than or equal to f of x for all x in the interval. In our picture I had a bit ago, suppose this is our graph. Here's A, and here's B. And it would appear this is the minimum value here, and it occurs at this value C. Now, if you can have a minimum, then you certainly ought to be able to have a maximum. F of C is a maximum value for f of x on I if, and this is the other side of the coin, if f of c is greater than or equal to, if it's the largest value, if it is the highest value on the y-axis used in the picture. So in my particular case, where I've drawn this little picture here, f of c is greater than or equal f of x for all x in the interval. It would appear, if I'm talking about maximum, that's the value of c I want, because this value, f of c, is greater than or equal to all f of x values for any other x in the interval, including the endpoints. Now, we are not required to include the endpoints. All we're required is to have an interval. And so it's entirely possible that we don't include the endpoints. And if that's the case, that doesn't matter. This is still the maximum value. In this particular case, let's call this one C sub 1. That's the maximum, f of c1. And let's call this one C subscript 2. Then this is f of c2. And then what I would say is f of c2 is the minimum value. F of c1 is the maximum value. Remember, what is the maximum? Your answer is a y coordinate. Where does the maximum occur? Where does the maximum occur? Your answer is not f of c1. Where does the maximum occur? Your answer is x equals c1, or simply c1. Where does the minimum occur? X equals c2, or simply c2. Now, there are many, many types of scenarios here. Let's consider a specific case that we're all fairly familiar with. Let's consider, as a specific example, let's consider f of x equals sine of x on the interval from 0 to 4 pi. I'm going to go from 0 to 4 pi. So that's 2 periods of the sine curve. And I'm going to draw a rough sketch of that here. Here's 1, here's negative 1, 1, 2, 3, so there's pi. That means there's 2 pi. That means that's about 3 pi, which means that's about 4 pi. And I'm going to just roughly sketch in this graph. This is pi over 2, 3 pi over 2. This is 5 pi over 2, 7 pi over 2. Node peak, I just taught this in basic trigonometry class the other day. And then we have peak, node, trough, node. And now I'm going to just roughly sketch this in. And this is going to be a very terrible picture. But you know what the picture is supposed to look like. You get the basic idea. So, there are 2 questions. Actually, there are 4 questions here. What is the maximum value? All right, I have written the word maximum and the word minimum about as many times as I'm going to write the word maximum and minimum. You do this about 3 times and you get tired of writing maximum and minimum, and so you write max. I'll either say, sometimes I'll say max, sometimes I'll say maximum, but I will typically only write max. So this is the standard abbreviation for maximum. Anyone who knows what you're doing says maximum. So we're talking about f of c is a max value. That's just the way people talk about it. We have the max and the min, just like we have the max, minimum and maximum. We have the min and the max. So what is the maximum value for f of x on this interval 0 to 4 pi? And then where does the max occur? Those are two separate questions. What is the maximum value? Your answer needs to be a y coordinate. What is the maximum value? Well, we know what it is. The maximum value is 1, because that's the highest point on the sine curve, the basic shape sine function. So what is the maximum value? So the maximum value is 1. Or if you prefer, you can write 1, or if you prefer, y equals 1. Where does the maximum occur? Now your answer needs to be the x coordinate. It occurs at pi over 2, but notice there's a tie. If there is a tie, if the maximum occurs at more than 1 point, then you list them both. If the maximum occurs at more than 1 point, you list them both. I say again, if the maximum occurs at more than 1 point, you list them both. If it occurs at 6 points, list all 6 of them. You list all the x values at which the maximum occurs. So in this case, we're limiting ourselves to 0 to 4 pi. Where does the max occur? It occurs at pi over 2. And what's the other one? At 5 pi over 2. If you wish, you may simply write that. Or if you wish, you may say x equals pi over 2 and x equals 5 pi over 2. This is a little more formal. This is just as correct. So you may say y equal 1, or you may say 1. X equals and y equals is probably a little bit more formal. So, and then we can ask the same question for the minimum, right? What is the minimum value? What is the minimum value? The minimum value is, we can say y equals -1. And where does the minimum occur? You can say minimum, but all you have to have right is min, min. Where does the minimum occur? If it occurs at more than one point, list them all. If there are 3, if there are 6, if there are 7, if there are 2, list them all. So in this case, we're going to list 3 pi over 2. And what's the other? 7 pi over 2. And we know all this information because of our acute knowledge of the graph of the sine curve. All right? So that's the notion. Notice we have the maximum occurs here, the maximum occurs here. All right? So we have now a Latin lesson. This graph has a maximum. This graph has a maximum. This graph has a maximum. Here, 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 wherever they are. So we might say on all 3 of these graphs, find the maximum value. Or we might say find the maximums. Well, maximums isn't really correct. I'm from the Midwest. I grew up in Missouri, so I do speak incomplete language. So I will know what you mean if you write this. But you shouldn't write this. The singular is this graph has a maximum. These graphs have not maximums, they have maxima. A Nissan Maxima is actually a plural word. It just sounds cool, so they used it. All right. So I'm going to clear this out a little bit. I'm going to talk about our little Latin lesson here. singular, plural. I feel like I'm teaching a foreign language here. Singular, maximum. If you have more than one, they are called maxima. Singular is a minimum. If you have more than one graph, you're talking about several, they are minima. And this next word is rather like this. Suppose we're talking about Great Danes and we're talking about Chihuahuas. We're talking about Great Danes and we're talking about Chihuahuas. Well, if you want to talk about these together as one category, you don't want to say Great Danes or Chihuahuas. You want to talk about them in one category, you simply use the group word for them, dogs. And you may have one dog or you may have more than one. They may be called dogs. Well, similarly, if you have a maximum and a minimum and you want to talk about them together, there is a word that means either maximum or minimum. It is called an extremum. The definition of an extremum is either a maximum or a minimum. This is an extremum because it is either a maximum or a minimum. This is an extremum because it is either a maximum or a minimum. Extremum, extremum. Extremum is the collective term for these things. Just like pride is the collective term for lions. If you have a group of larks, interestingly, they're called an exaltation of larks, in case you're ever on Jeopardy. And so if you have one of them, it is an extremum. If you have several of them, what's the plural of extremum? It is the word we started with. Extrema. Extrema may be either maxima or minima. So find all the extrema. That's the simplest way of stating the question. Find all extrema, which means find all the maxima, which means find all the minima. And if you're from the Midwest like I am, I grew up in Missouri, what that means is find all the maximums and find all the minimums. It's actually maxima and minima. So that's just the language, and that's the Latin lesson for the day. Singular, plural, maximum, minimum, extremum, maxima, minima, extrema. This means either these kind. This means either of these kind. All right? And so that's our terminology we're going to be using. Now, the last little bit of this for now is the phrase absolute. We can have an absolute maximum. We can have an absolute minimum. We can have absolute extremum. Now here's what that means. Absolute means of the entire interval, it is the highest, it is the lowest. So here's our picture here. Consider a little bit more complicated picture here. On the interval I, so let's suppose we have the closed interval here, so let's include the endpoints. So on the interval from A to B, we have the absolute maximum, which is overall the absolute. Sometimes you'll hear this word. You'll hear the word global. I tend to use absolute. That's probably a little more common. But if you ever hear a global max, it means the same thing as an absolute maximum. This is the absolute max. And that's the abbreviation for maximum. This is the abbreviation for absolute. Absolute maximum. The absolute maximum is this point. The absolute maximum is, let's call this C number 1 as the buzzer goes off. This is F of C number 1. That's a long buzzer. And then this is the absolute minimum because it is the lowest one of all. Let's call this C number 2. So this is F of C number 2. This is the absolute maximum. This is the absolute minimum. The absolute max occurs at C1. The absolute min occurs at C2. But we also have another type because something's going on here and something's going on here. It's related to what's going on here, but it's not quite the same. This is related to what's going on down here, but it's not quite the same. And there goes the buzzer again. We have the relative max and the relative minimum. Relative means, well, if you only look here, relative to just this piece of the picture, that's the maximum. If you only look here, if you limit your scope to just that little region, then this is the minimum. If you limit your scope just to that region, that's the maximum. So this is a relative minimum. This is a relative maximum. But this and this is the absolute minimum, the absolute maximum. Let's call this one C number 3, and this is C number 4. That's the dryer going off. I think it's finally finished. And so there is a relative minimum at C4. The relative minimum is F of C4. There is a relative maximum at C3. The relative maximum value is F of C3. There is an absolute minimum at C2. See the difference between absolute maximum and relative maximum. Absolute minimum and relative minimum. It's rather like this. Imagine we have an elementary school, and imagine there are 40 rooms in this elementary school, 40 classrooms. Each individual classroom has the tallest student in the classroom. Now, there might be a tie. There might be several students the same maximum height. But let's assume that all the students in the elementary school are different heights, just for simplicity. So, in room number 1, there is the tallest student in that classroom. Now, that is the tallest student in that classroom. Is it clear? That does not necessarily mean that that student is the tallest one in the school. Because the next classroom over, there is also a tallest student. So, each of these is called a relative maximum. Relative to that classroom, it's the maximum height. Relative to that classroom, it's the maximum height. And then relative to another classroom. So here's classroom 1, here's classroom 2, maybe here's classroom 3, maybe here's classroom 4, maybe here's classroom 5, classroom 6. So each classroom has its own individual relative maximum. Now, we also know somewhere in the school, there is the actual tallest student, right? So somewhere in the school, there's the actual tallest student in that classroom. Now, if all we did was measure the students, we might not know. If all we do is measure the students in our classroom, we might think that this student, Chris, is the tallest student in our classroom. That's all we know. Chris is a relative maximum, or Chris's height. Chris's height is the relative maximum. Now, it turns out Chris might also be the absolute maximum. So, every absolute maximum is also a relative maximum, relative to that region, relative to that neighborhood, relative to that classroom. Every absolute maximum is also a relative maximum, but not every relative maximum is an absolute max. Now, we could do the same thing for the shorter students, right? We could do the same thing for the short, and we could have the absolute minimum and the relative minimum. And so that's what's happening in a picture rather like this. So this could be a little bit more complicated picture. All right. Here's A, here's B. Now, in this particular case, this does not always occur, but I've drawn a special graph just for this purpose. In this particular case, we have several relative max, relative min. Let's find all the relative max values. Can you find all the relative max values in my picture? How many are there? I see 1, 2, 3, 4, 5. Is it clear? There are 5 relative max values, and there are 1, 2, 3, 4 relative min values in my picture here. Let's change my little definition here. Let's make this an open interval so my statement is now correct again. There are 1, 2, 3, 4, 5 relative maximum values. There are 1, 2, 3, 4 relative minimum values. Do you see all 5? Here's a relative max, relative max, relative max, relative max, and relative max. You said, but wait a minute, this is absolute. Well, that's true. But remember, in this classroom, that's the tallest student. That's a relative max. In this classroom, that's the tallest student. That's the relative max. In this classroom, that's the tallest student, relative max. In this classroom, that's the tallest student, relative max. In this classroom, that's the tallest student, relative max. All of these are relative maxima. But only one of them is the absolute maximum in this case. This is the absolute maximum. And so a relative maximum means this. The technical definition is this. This is a relative maximum at C if there exists an open interval containing C, if there exists an open interval containing C, and if on that open interval, if we erase everything in the picture except this open interval, it would look like this. If we erase everything in the picture except that open interval, that would be the picture. If on that open interval, C is the absolute max just for that interval, then C is the relative maximum there. That's a lot of words. It's a lot of terminology. It's easier just to see. Relative max, relative max, relative max, relative max. Yes, relative max, but also this one is the absolute maximum. And similarly, relative minimum, relative minimum, relative minimum, and relative minimum. But this one is this is the absolute minimum. Let's call this C number 2. So F of C number 2 is the minimum value, the absolute minimum value. And the absolute minimum value is F of C2. It occurs at C2. Let's call this C3 and call this F of C3. The maximum value is F of C3. It occurs at C3. We'll take a much closer look at all these and the variations on this theme in our subsequent upcoming videos.